We're going to be looking at chapters 10 and 11 next, and we're going to put those into one test. So, chapter 10 is looking at gases, and 10.1 specifically, the kinetic molecular theory of matter. So, some things to look about when you are spraying a can, why are there often safety warnings? Like, think of an aerosol can, paint, sometimes you see hairspray, things like that in those cans. Why do they have safety warnings? Um, so, what can cause them to become dangerous? Some things, often you maybe see, don't heat them up, don't get them near a flame, because if we heat up air particles, they're going to move faster and faster and they're going to want to spread out. So, in a can like this that can't move very easily or expand very easily, it's just going to explode. So, we're going to be looking at properties of gases like that throughout this chapter. So, first of all, the kinetic molecular theory says that particles of matter are always in motion, and kinetic itself means that things are moving. So, when we're looking at solids versus liquids versus gases, no matter what state something's in, those particles are always going to be moving. They may be faster or slower in different states, but they will always be moving. So that's going to explain the difference in solids, liquids, and gases. An ideal gas is going to be kind of theoretical, imaginary, that fits all of these rules or assumptions of the kinetic molecular theory that we're going to talk about next. So, first of all, gases consist of tiny particles spaced far apart relative to their size. So, we have to think about the fact that particles are very, very, very small, but compared to one another, those particles are going to be spread out very far, as opposed to if they were a solid or a liquid, where they would be a lot closer together. Number two, we're looking at collisions. So, collisions between these gas particles and anything else they may run into are going to be called what's elastic. And so, if it's an elastic collision, there's going to be no loss of kinetic energy. So, if I were to throw out a bouncy ball at a wall, if I throw it at that wall, it's going to bounce off with the exact same speed that it hit the wall, which isn't really true what happens. But according to the kinetic molecular theory, gas particles do behave that way. So, if we threw a bouncy ball at a wall, it's going to hit the wall and it's going to lose some of its energy to the wall, the heat, the sound, different forms of energy. But according to this, elastic collisions, there's not going to be any loss of energy with these particles bouncing around and hitting walls, containers, whatever they're touching. Number three, gas particles are in continuous, rapid, random motion and possess kinetic energy. So they're always moving, it's random, and they're always going to be continuing to move. Number four, there's no net force of attraction or repulsion between gas particles. For the most part, this is going to be true, but there are going to be particles that have talked about that might have positive or negative charges, and so they're going to want to repel or attract depending on how charged they may be. Number five, the average kinetic energy depends on the temperature of the gas. So if you think about solids, liquids, and gases, to change from a solid to a liquid or a liquid to a gas, you have to add heat. And so as you add that heat, you're causing those particles to move faster and faster. When we look at the kinetic energy equation, it's 1/2 times the mass of the object or the particle times the velocity of that particle squared. So again, the KE is going to increase as the temperature increases. Some properties of gases, first of all, expansion. They do not have a definite volume or shape, and this is something that you've probably learned grade school definition. But this is because they expand. So, whatever type of container you put a certain amount of gas in, it's going to expand and spread out to fill that container. And you can think of this if you have um, a perfume, possibly. That perfume, you may spray one spray of that perfume on one side of the room, and then in a few minutes, you may be able to smell that perfume on the other side of the room where those particles have expanded throughout the room. Fluidity. Often we think of fluids as liquids, but really fluids are liquids and gases. It just means that the particles can glide easily and flow past each other. Low density. So we know that density um, is depending on the mass of the object and how compact that mass is. So if particles are spread out in gases more than, let's say, solids, gases are going to have low density. Compressibility. This is a term that a lot of times students get confused on. If you think of compressing something or squeezing it, if you have a balloon, let's say, filled with gas, air, helium, you can squeeze that balloon and it's going to give. If I put rocks in the same balloon and tie it off, it's not going to compress. Diffusion and effusion. So, very similar words, but a little bit different definition. So, with diffusion, we're going to have particles of two substances that can pass by each other randomly. So, if you think about air is made up of different gases. We've got oxygen and nitrogen and carbon dioxide all in the air, but they're not chemically combined. They're mixing and they're flowing past each other, they're diffusing. Effusion is where you have gas particles passing through tiny openings or tiny holes. If you think about a helium balloon may not stay where it's rising up to the top of your room because it actually has tiny holes in that balloon that over time the helium's going to escape or effuse out through the balloon. So a real gas is not going to follow all of these principles of the kinetic molecular theory. There are going to be factors such as maybe it has a slight charge that are going to make it not follow all of those rules perfectly. High pressures and low temperatures are typically where real gases don't behave ideally.